Hi, I'm Bryant, tutoring high school physics. Today's topic, vector and scalar quantities and basic kinematics. There are two major types of measurements in physics, scalar and vector measurements. Scalar measurements don't take direction into account, whereas vector measurements do. So let's take a look at some of them. Distance is a scalar measure of space, and we're going to measure that typically in meters. Displacement is a vector measurement of space, and it's defined as the distance between your starting point and your ending point. We can illustrate that mathematically. Physicists will typically either use an S or a delta x to illustrate displacement. I prefer delta x because you can expand that one out. Delta means the final value minus the initial value, and x is just your position. So essentially, your final position minus your initial position, which gives you the distance in between. So x position sub f, so final position, minus x sub I, where I stands in for initial, so your initial position. Okay, so let me illustrate this. Let's say you walk down a 100-meter stretch. Distance-wise, that's 100 meters. Displacement-wise, also 100 meters, because the distance between your starting point and your ending point is 100 meters. Let's say you walk down the stretch and then you walk back. Distance-wise, 200 meters, so that's 100 meters twice. Displacement-wise, however, your starting point and your ending point are at the same place, so 0 meters of displacement. Let's move on. Speed is how fast you're going, and typically in physics we'll measure that in meters per second. Velocity is also how fast you're going, but it's a vector measurement, so it takes direction into account. What this means, every time you see velocity, the first thing you should do is define a direction as positive. Which direction do you have to define as positive? Doesn't matter. Completely up to you. Just remember that the opposite direction must be defined as negative. So let's say you're up with a car and it's traveling north. You have to define one direction as positive, so let's just pick north. That way south would be the negative direction. Again, it's completely arbitrary. I could pick south as positive, but instead I'm just picking north. So your car is traveling north at 60 meters per second, and that's 60 meters per second of speed and of velocity, but then turns around and goes 60 meters per second south. Still 60 meters per second of speed, but negative 60 meters per second of velocity. We can illustrate velocity numerically, and we're actually going to do the average velocity. So v is what stands in for velocity, and we're going to put a bar over it to show that it means average. Bar over any particular symbol will mean that it's the average version of that particular measurement. So this is going to be equal to the displacement divided by time. So we can actually expand that out to our final position minus our initial position over time, because recall that's displacement. Last up, acceleration. So you notice acceleration is a vector quantity. Remember those directions you defined for velocity? You're going to keep those directions for acceleration. Now acceleration is the rate of change of velocity, and it's measured in meters per second per second. So you can think about it as the change in velocity in meters per second every single second. So to illustrate this, let's say you're traveling at 5 meters per second, and you have an acceleration of 5 meters per second per second. That means every second you're going to go 5 meters per second faster. So you're going to start at 5, and then you're going to go 10, then 15, so on and so forth. Some rules to remember about acceleration. If acceleration and velocity have the same sign, then your speed is increasing in that direction. So if they're both positive, you're getting faster in the positive direction. If they're both negative, you're going faster in the negative direction. However, if they have opposite signs, one is positive, the other is negative, you're going to be slowing down. Your speed is going to be decreasing, your velocity is going to be approaching 0. So say you're traveling with positive velocity and negative acceleration, your positive velocity is going to keep decreasing until it hits 0. However, let's say you're traveling in the negative direction with negative velocity, but with positive acceleration. Your speed in the negative direction is going to decrease, but your velocity is going to be considered increasing until it reaches 0. We can demonstrate acceleration numerically, in fact average acceleration. So a bar equals the change in velocity over time, delta v. So we can expand this out to velocity sub f for final, minus velocity sub I for initial, divided by time. To recap, there are two major kinds of measurements in physics, scalar and vector measurements. Scalar measurements don't take direction into account, whereas vector measurements do. Distance is the scalar measurement of space, and this is going to be measured in meters. Displacement is the vector measurement, symbolized by an s or a delta x, and is defined as the distance between your starting point and your end point. Speed is the scalar measure of how fast you're going, typically in meters per second. Velocity is the vector measurement of how fast you're going. With velocity, you'll have to define a positive direction, and the opposite direction will be negative. You can represent velocity with a v, and the average velocity is defined as the displacement divided by time. Now finally, acceleration. Acceleration is the rate of change in your velocity, and you're going to keep the same directions that you define for velocity for acceleration. If velocity and acceleration have the same sign, then speed is increasing in that direction. If they have different signs, then speed is decreasing. Acceleration is defined as the change in velocity divided by time. Alright, that's all for now. Again, I'm Bryant. See you next time.